Okay, now there's one last item that I want to discuss, and that is feature scaling. Feature scaling. So feature scaling, sometimes called feature normalization. Normalization. Okay. You could have, for example, a situation where one of your features x1 ranges from 0 to 5 and your other feature ranges from 0 to 20,000. Yeah. It's an issue, huh? If you're gonna draw this in a graph, yeah, if this is x1 and this is x2, you're gonna have a very long and flattish type of situation. Yeah, your contour lines will go from 0 to 20,000 in this direction. Yeah, is the height, and then like this is only from 0 to 5. So here you see that your variance with respect to x1 is way smaller than the variance with respect to x2. Sorry, it's very big difference in size. So that means that gradient descent will converge slowly. Right? Imagine you start somewhere, you gotta go all the way up. This will actually hinder nice convergence. So what do we do to solve this? We do normalization of data. Normalization of data. And it's something that you see in statistics as well. Sometimes in statistics, when you have a distribution like this, and your mean is equal to mu, and your standard deviation equals to sigma, sometimes we do a transformation, and convert this in a situation where your mean is 0 and your standard deviation is 1. Yeah. So this is the normalized Gauss curve. In order to go from this to this, let's call this the z. So in order to go from x to z, you basically take x, you subtract the mean, and you divide by the variance. You divide by the standard deviation, sigma. Yeah. So once you do this, yeah, this picture will become nicer. This picture will become nicer, centered around 0, and variances within check. Yeah. And of course your gradient descent here is going to be much more fast to the minimum. So in general I would say that feature scaling and mean normalization are a very good practice. It's I would actually recommend to do it almost every time. Okay, that was it for the gradient descent lesson. I know it's a very technical lesson, but at least try to get the intuition. When we do machine learning, we're gonna deal with many dimensions. It's something we cannot grasp anymore. But if you understand the two-dimensional or the three-dimensional case, you at least know what is going on.